Alright, evaluating the six trigonometric functions given the coordinate point. Alright, so say you're given the point 3, 4. You draw your graph or diagram, and you label the x-axis 3 for the 3 from the point given, and be at the point 3, 4, and then the y-axis the 4, and then you draw from that point to the terminal side, or point 0, 0, and for this, I'm going to actually use a pre-made diagram to show you. Alright, so we have the point 3, 4, and this is a pre-made diagram that I made, and I have the 3 labeled on the x-axis, which is where we get the length of the adjacent side as 3, and the y-axis length, or opposite side length of 4. And what is the x? The x, you have to use the Pythagorean theorem to solve for, which is solving for the hypotenuse, and a squared plus b squared equals c squared. So 3 squared would be 9, 4 squared would be 16, that would add to 25, and then the square root of that would give you 5, so x equals 5. And then you can use this information you now know to figure out all of the trigonometric functions. All right, given 3, 4. Alright, so we've already worked with this diagram. We now know that x equals 5, and using this information that we have from the diagram that we made, we can find the function. So starting with sine of theta, which is the opposite over the hypotenuse, the opposite being 4 because it's opposite of the terminal side or the angle, and the hypotenuse being 5. So that would make sine of theta 4 over 5. Then moving on to the reciprocal function, which is cosecant of theta, that would be the hypotenuse over the opposite, or you just switch the hypotenuse and opposite, so that'd be 5 over 4, and then cosine of theta equals adjacent over hypotenuse. Adjacent being 3, and then hypotenuse being the 5, which we already determined. So that would mean cosine of theta equals 3 over 5. And then moving on to the reciprocal of that, that would be secant of theta, which equals the hypotenuse over adjacent. So you just switch the adjacent and hypotenuses places. And that would be 5 over 3. And then tangent of theta would be the opposite over adjacent. So that would be 4 over 3. And then the reciprocal of that would be cotangent of theta. And cotangent of theta, it'd be adjacent over opposite. You just switch opposite and adjacent's place. And then that'd be 3 over 4. Alright, and then if you have trouble remembering which reciprocal function goes with which concerning sine and cosine, it's always going to be the opposite letter. So sine starts with an S, and then its reciprocal is cosecant, which starts with C, and then cosine, its reciprocal is an S, and cosine starts with C, so it's opposite. Alright, given the point -6, -7. Alright, so you draw your graph, and the point would be in the third quadrant, because they're both negative numbers. and you label the x-axis with the -6 and the y-axis with -7. And you draw the point at -6, 7, and then you draw a line from the points to the terminal side or the origin. But for the sake, we're going to use a pre-made graph or diagram that I made. Given the point -6, -7, find all 6 trigonometric functions. So this is a diagram that was pre-made, that I made, and then so first thing you do is find out what x is. And to do this, you use the Pythagorean theorem, which is a squared plus b squared equals c squared. And so that'd be -6 squared plus -7 squared equals c squared. And so -6 squared would be positive 36, because negative times a negative would be positive. And then -7 squared would be 49, and that would 36 plus 49 equals c squared. So 85 equals c squared. And then you square root that to get rid of the squared. And so x equals the square root of 85. Right. So given the point -6, -7, find all of the trig functions. So this is the diagram that you've already seen by now that I made. We figured out that x equals the square root of 85, and using this information we can figure out the different trig functions. So the first one is sine of theta, which that equals the opposite over the hypotenuse. And for this, the opposite would be -7, and the hypotenuse would be the square root of 85. So first you would write it like -7 over the square root of 85. But that's not the correct way to write it, because you can't have a square root in the denominator, so you multiply it by the square root of 85 over the square root of 85 to get rid of the square root in the denominator. And so sine of theta equals -7 square root of 85 over 85. And then cosecant, the reciprocal of that, you switch the opposite and the hypotenuse, and when you do it, use the original, not the new one. So use that one, and so it would be the square root of 85 over -7. Alright, so now moving on to the next trig function that we're going to find. So the next trig function that we're going to find is cosine of the theta. And so cosine of theta equals the adjacent over the hypotenuse. So the adjacent side in this case would be the -6. So when you write this first, you're going to write it -6 over the square root of 85. Though that's not the correct way to write it. In order to get the square root out of the denominator, you have to multiply it by the square root of 85 over 85. And that's to get the square root out of the denominator. So eventually you get a final answer for cosine of theta. So cosine of theta would equal -6 square root of 85 over 85. And then in order to get the reciprocal function, the secant of theta, you'd reverse, or you'd swap the hypotenuse with the adjacent, and make sure to use the original one, this one, when doing this. So it'd be the square root of 85 over -6. Alright, so moving on. Next we're going to find tangent of theta for -6, 7. So tangent of theta is opposite over adjacent. And so for this it would be 7 over 6 because the two negatives would cancel out. And then for the reciprocal of this, which is cotangent of theta, it would equal 6 over 7 because the opposite and the adjacent just swap. And that's all for this problem. Alright, so given 17, -4, point on the coordinate plane, find all the trig functions. So first you draw your graph or diagram again. And you label the points where they're at, x at 17, -4 for the y, and you draw your line to the terminal side or the origin. But I'm going to be using a diagram that I made already. Alright, so we already given the point 17, -4, and we're supposed to find all the trig functions given this point. Alright, this is the diagram that I made, and first we need to figure out what is x. So to do this, you'd use the Pythagorean theorem. A squared plus b squared equals c squared. So in this case, it would be -4 squared plus 17 squared equals c squared. And -4 squared would be -4 times -4, which would be positive 16. And then 17 squared would equal 289. And then when you add that together, that gives you 305. So 305 equals c squared. Then you square root that to get rid of the squared. So x equals the square root of 305. Alright, so we're already at the point given 17, -4, and we're finding all the trig functions given this point. Alright, we now know that x equals the square root of 305. So the first trig function that we're going to find is sine of theta. And that would be opposite over hypotenuse. And that'll be -4 over 305. And then you can't have it written like that, so you have to get the square root out of the denominator, so you multiply it by 300, the square root of 305 over the square root of 305. Then your final answer for sine would be -4 square root of 305 over 305. And then the reciprocal of sine is cosecant, and cosecant of theta would be the hypotenuse over opposite rather than opposite over hypotenuse. So make sure you use the original one that you started with, and you get square root of 305 over -4. Alright, so the next function that we're going to be working on is cosine of theta. And cosine of theta equals adjacent over the hypotenuse. So it would be 17 over square root of 305. And then that's not the correct way to write it because you can't have the square root in the denominator, so you multiply it by the square root of 305 over the square root of 305. And then that'll give you your final cosine answer. So it will give you cosine of theta equals 17 square root of 305 over 305. And then for the reciprocal function, you switch the adjacent and the hypotenuse, so it'll be hypotenuse over adjacent rather than adjacent over hypotenuse. So secant of theta, and make sure to use the original one, 17 over square root of 305. So secant of theta will equal the square root of 305 over 17. Alright, so the final set that we're going to be finding is tangent and its reciprocal function. So tangent of theta equals opposite over adjacent. And so that would be negative 4 over 17. And then the reciprocal of that would be adjacent over opposite, and that would be cotangent, and cotangent of theta would then equal 17 over negative 4.